the last class, we discussed about the ruby laser law in the last class, right? So what is the active medium in the ruby laser? Can any one of you please tell me the active medium and active particles in the ruby laser? And pumping mechanism. We discussed now about the ruby laser in the last class. So what is the active medium in that, and what is the active particles, and what is the resonant cavity, and what is the pumping mechanisms, and where we achieve the population inversion, and how much the wavelength is produced in the ruby laser. For these questions, I want answer from your side, Amma. Please, can any one of you? Simply listening the classes, not listening the classes, only join to the classes for attendance purpose, I think. So this is a ruby crystal I have taken. So two ends of the ruby crystal are silver, and these are the two ends. So in that, aluminum oxide ions are present, Al2O3, ruby crystal, ruby rod. I am not mentioning the dimensions. Ruby crystal. So for that, I am adding Cr3 O2 chromium oxide ions, or Cr3 O2 chromium oxide ions in the percent of 0.05. Because of when we given the xenon flash tube as a pumping source. From the flash lamp, only blue and green absorption. Out of 7 colors, only green and blue absorptions are observed by the chromium particles. Within the chromium energy levels, we are getting the laser. That's why your active particles are chromium. So two ends of the ruby crystal are silver. These two ends are acted as a resonant cavity. So one end is fully silver. At the same time, the other end is partially silver, means 95% silver. Sorry. And this ruby crystal I am keeping in xenon flash tube, helical xenon flash tube, which is connected to the power source and capacitor bank. The capacitor bank, and this is the battery. So total operation we are taken within the cooling chamber. Here I am giving inlet and outlet. Here liquid nitrogen or cool water you are used as a coolant here. This is the inlet and this is the outlet. Liquid nitrogen or cool water. Are used as a coolant. Same thing here also. This is a cooling chamber. So in that, active particles are chromium particles. Active medium is ruby crystal. Active medium. All of you try to remember these active medium and active particles, pumping mechanism. These are all the things all of you try to remember. Active medium is ruby crystal. Ruby crystal. Within the chromium energy levels, we are getting the laser. Active particles are chromium particles. So after that, resonant cavity to give the optical feedback to the photons. Optical cavity is two mirrors, two ends of the ruby crystal. These are two ends of the ruby crystal is acted as a resonant cavity. And pumping mechanism. Pumping source is pumping source is a xenon flash tube. This one, xenon flash tube. When the capacitor bank discharges the energy, that energy or flash lamp circulated within the flash tube, and from the flash tube only blue and green absorption is observed by the chromium particles from the ground state and excited to the higher energy states. That is the process. I will explain with the by taking the energy level diagram. So before that, see, active medium is the ruby crystal again. Active particles are chromium particles, and resonant cavities, two ends of the ruby crystal are acted as a resonant cavity. One end is fully silver and one end is partially silver. And pumping source is a xenon flash tube. So remaining one is energy level diagram. Coming to the energy level diagram. So I'm drawing the energy level diagram. This is an example for 3-level scheme. So ground state usually we are taken as E1, and E2 is called as a metastable state because of atoms are holding chromium particles are spending maximum time. E3 and E4 I'm treated as only one energy level. That's why this is an example for 3-level scheme. So chromium particles from the ground state. When the power bank is switched on, what will happen? When the capacitor bank is switched on, what will happen? Energy is circulated and flash lamp is circulated within the flash tube. From the flash lamp, only green and blue absorptions are observed by the chromium particles from the ground state and excited to the higher energy state. So after staying some time, by the stimulator emission process or by interacting with the crystal lattice, what will happen? Chromium particles losing some energy. So by losing some energy, they are de-excited to the next energy level, nothing but E2. And this is we call as a non-radiative transition. No energy is released, non-radiative transition. Radiative transition. These also non-radiative transitions. So here atoms are spending maximum time because of it is called as a metastable state. What is the purpose of metastable state? Atoms holding in the energy level, that energy level holding maximum time. So particles are goes on increasing here. At the same time, by the pumping sources, we are continuously sending to the E3 and E4 now. So here particles are goes on decreasing. Here particles are goes on increasing. So at a particular instant, what will happen? So E2 having more number of atoms than the E1. Nothing but when we achieved the more number of atoms in the higher energy state than the lower energy state is called as population inversion. Means in the ruby crystal, we are achieved the population inversion between E2 and E1. So after achievement of population inversion, what we are going to observe? The laser transition will occur in between the E2 and E1. So how much the wavelength is produced in the ruby laser? 6943 angstroms of wavelength is produced. 6943 angstroms of wavelength. So which is in red color. Okay, so for example, this is the first coming atom to the metastable state. So after completion of lifetime, what we are going to observe? By the spontaneous emission, the atom is de-excited to the ground state energy level. So by the spontaneous, that's why. So here only one photon is released by the spontaneous emission process. So but the source to get the laser is stimulated emission of radiation. To start the stimulated emission of radiation, we are using the spontaneous emission. So this energy may be supplied to the one atom in the metastable state. So this energy absorbed by the particle or photon energy is interacting with the atom, which is in the metastable state. So by observing this particle, it is de-excited to the ground state energy level. That's why stimulated emission of radiation will starts, and more means two photons are released here, H-nu and H-nu. Right? These two again supplied to the two more atoms in the metastable state, are absorbed by the two more atoms in the metastable state and de-excited to the ground state energy level. So within the two photons are released, 1 and 2, 3 and 4. These 4. Again these 4 supplied to the 4 more atoms in the metastable state and de-excited to the ground state energy level by the stimulated emission of radiation. So here to start the stimulated emission of radiation, we are using this spontaneous emission of radiation sometimes. Right? By interacting with the crystal lattice, they lose some energy in the E3 and E4 energy states, and by the non-radiative transition, they are in the metastable state. So metastable state holding maximum time, that atoms are spending maximum time in the metastable state. Here atoms are goes on increasing, at the same time using the pumping source, here atoms are goes on decreasing. So at a particular instant, we observe the population inversion. After the population inversion, laser transition is occurred in between the E2 and E1. So the wavelength produced in the ruby laser is 6943 angstrom units. So then which is in red color. And this is about the ruby laser. Same thing in the helium-neon laser also. So is it clear to everyone? Please tell me. I want to know, is it clear to everyone or not? Please respond by raising your hands. By raising your hands, please respond. Only 63 raised. 65.
Sir, start. ఇంకొకసారి చెప్పండి సార్ షార్ట్ గా ఇక్కడ లాస్ట్ పాయింట్స్.
ఓకే ఓకే So coming to the sorry,
stimulated emission తర్వాత చెప్పండి సార్.
Stimulated emission. Here stimulated emission will start. Actually, I will draw the diagram very clearly here again. So here 3 energy levels are present. Ground state energy level first of all, E1. So this total action takes place within the ruby crystal, and E2 is the metastable state now. E2 is a metastable state, MSS, metastable state. E3 and E4 looks like a single energy band, blue and green absorption. E4 is belonging to blue and E5 is E3 is belonging to green. So from the ground state, chromium particles are only responsible for the pumping source. What is the pumping source here? Xenon flash tube is the pumping source. From the flash tube, only green and blue. This is blue absorption, that's why it is appear in green absorption, E4, and this is a blue absorption. Which particles absorb the blue wavelength? They are in the E3 state, and which particles are absorbed green wavelength? They are in E4. They are excited to E4 energy state. So after that, by interacting with the crystal lattice, what will happen? We are observing the particles are losing some energy. So when they are losing some energy, they are de-excited to the next state energy level, nothing but E2. So already they are losing some energy. There is no more energy is released. That's why we call as non-radiative transitions. Non-radiative transitions. So here atoms are sending continuously to the higher energy states. By interacting with the crystal lattice, they are losing some energy and they are de-excited to metastable state. So in the metastable state, these particles are spending maximum time. That's why it goes on increasing continuously. Goes on increasing. At the same time, particles in the ground state are goes on decreasing. At a particular instant, what we are observing, E2 is greater than E1. Means the number of particles in the E2 state is greater than to the E1, nothing but population inversion. Means population inversion we achieved in between E2 and E1. After achieving the population inversion, what we are going to observe? Only laser transition. Laser transition is occurred in between the E2 and E1. So for example, stimulated emission of radiation is the source to get the laser. To start the stimulated emission of radiation, so we need to give some energy to the particles in the E2 state. So where we have to give that energy? So there is no possibility to give directly energy to the atoms in the which are available in the metastable state. That's why, for example, this is the first coming particle to the metastable state. After the completion of lifetime, what we are going to observe? So the spontaneous emission will occur in between the energy levels. So for example, this atom having some 3 seconds of lifetime. After 3 seconds, what will happen? So the atom automatically de-excited to the ground state energy level. That is called stimulated emission of radiation. Right? That's spontaneous emission of radiation. So that's why only one photon is released. So that photon may be interacting with the one more atom in the metastable state. By interacting with by observing some energy, what will happen? This atom de-excited to the ground state energy level. That process we are calling as a stimulated emission of radiation. Means stimulated emission of radiation will starts now. So here 2 photons are released. So these 2 photons may be supplied to the 2 more particles in the metastable state. So again, these particles absorbing this photon energy and de-excited to the ground state energy level. So here 2 energies are released. 2 photons are released. Right? So again, these 4 photons are maybe observed by the 4 more particles in the metastable state. Four more particles and de-excited to the ground state energy levels. Means 4 are converting into the 8 photons. Here 2, all are 2. So again, these 8 more energies may be supplied, may be observed by the 8 more particles in the metastable state and de-excited to the ground state energy. In every transition, what will happen? We are going to observe photons are released by the de-excitation process. This energy may be supplied, converting into the laser beam. So this process up to wavelength produces 6943 angstroms of wavelength. This wavelength the process continuously occurred in between the energy levels. So by the pumping sources, particles are sending to the chromium particles are sending to the higher energy state. So after that, so they are de-excited to the metastable state by interacting with the crystal lattice, losing some energy. That's a non-radiative transition. So after that, by the stimulated or spontaneous emission, first by the stimulated or spontaneous emission, they are de-excited to the ground state energy level. So which are emitted by the stimulated emission of radiation, that photons are converting into the laser beam because of that photons only having high coherence, highly coherent sources. Okay now. So this process continuously occurs until unless the wavelength is produced 6943 angstroms. So we discussed in the last class about the applications also. To remove the tattoos, to create the holograms, or to create the holes to the iron rods. These are some applications we discussed already about the ruby laser. Okay, so what are the main drawbacks? Then this is a 3-level scheme. So eye pumping mechanisms are required. So there is a 3-level scheme. That's why. So we required eye pumping mechanism. And one more thing, this is not a continuous laser. This is pulsed laser. These are the main drawbacks of this ruby laser. It is not continuous laser. It pulsed laser. One more thing, this is a 3-level scheme. That's why eye pumping sources are required. These are some drawbacks about the ruby laser. Okay. At least now it is clear to everyone.
Yes, sir.
Now at least within 10 seconds only I am going to give. Please raise the hand. Within the 10 seconds, how many are going to raise the hands? I will see. 9, 10, 11, 12, 13, 14, 15, 17, 20. Only 20, 23, 25. Out of 51, 25 students are raising their hands. 26, 27. Okay. So 28, 30, around 30 students are raising their hands. Okay, no problem. So coming to the next topic, helium-neon laser. All of you keep the heading helium-neon laser. Before that, I want to show the PPT of ruby laser. Ruby laser. Is the PPT is visible?
Yes, sir.
Yes, sir.
Yeah. So coming to the starting point of lasers. So light abbreviation acronym of light amplification stimulated emission of radiation. First invented laser is ruby laser. What we discussed now, that is demonstrated by scientist Mamin in 1960. Mechanism of light, we discussed what are the mechanisms involved in the light emission. Only 3 mechanisms: absorption and 2 emission processes, stimulated emission, and one more is the spontaneous emission. So absorption, nothing but atoms in the ground state interacting with the matter. What will happen from the matter? Photon energy absorbed by the particles or atoms and excited to the higher energy state is called as the absorption. And in this first diagram represents before absorption, and after second diagram represents after absorption. And spontaneous emission, nothing but so excited atom not permanently stayed in the excited state, having particular lifetime. Only for that lifetime, it's only for a particular time it spends in the higher energy state. So after the completion of lifetime, what will happen? That atom automatically de-excited to the ground state energy level only by releasing one photon energy, one photon. So stimulated emission before completion of lifetime, what we are going to do? So in the excited atom, we are going to give again energy to that atom or interacting with the matter. So what will happen? Photon energy absorbed by the particle and de-excited to the ground state energy level. In this also, first diagram represents photon energy or photon absorbed by the atom in the higher energy state. In the second diagram represents de-excited to the ground state energy level with emitting of 2 photons. So these are the differences between the stimulated emission and spontaneous emission. Coming to the characteristics, 4 characteristics, try to remember. Monochromaticity means produced in a single wavelength or single color, and high degree of coherence, nothing but which are released by the stimulated emission process, all are within the phase. So that's why we can say that laser light having high degree of coherence and directionality due to its wavelength and coherence, they are traveling in a single direction over the kilometers without much spreading. So brightness also very high. So these are the 4 characteristics of lasers. So the divergence also we measure using the formula arc by radius. So coming to the population or population inversion, the number of atoms, the number of atoms in a higher energy state is greater than to the lower energy state is called as population inversion. So by getting the laser, we achieve the population inversion between the existing energy levels are merged. So So here also two diagrams are there. One diagram represents the population, usual occupation of population of energy levels of atoms. So second one is population inversion. Coming to the metastable state, which in which energy level atoms are spending maximum time, that energy level is called as a metastable state. So lasing action. So for the lasing action, we are using pumping, population inversion, and stimulated emission of radiation. Will in every type of laser, three actions are compulsory. So pumping, first using the pumping sources, we are sending the particles from ground state to the higher energy state. And population inversion is achieved between the energy levels by sending the particles from ground state to the higher energy state using the pumping mechanisms. So after achieve the population inversion, stimulated emission of radiation takes place between the energy levels. And this is the action takes place in every type of laser. A laser system, the main parts are consisting of laser system is active medium and energy source, optical cavity. These are the three basic parts. So after that, ruby laser, and these are ruby laser. So first type of laser demonstrated in the year of 1960 by T.H. Mamin is a solid state laser. Example for solid state laser, we have different types of laser: solid state laser, gas laser, liquid laser, okay, semiconductor laser. These are the types of lasers. In that, ruby laser is the example for solid state laser. Next, helium-neon laser is the example for gas laser. Okay, this is a pulsed 3-level pumping scheme. So active medium, the active medium in the ruby rod is chromium 3+ ions. So some of the aluminum atoms are replaced by chromium atoms. Lasing action takes place in the chromium energy levels. That's why active particles, I can say that chromium particles here 3+ ions. Energy sources, optical pumping, we call as optical pumping. Xenon flash tube circulated the flashed lamp. So this is a construction part. This is a diagram for ruby laser. Working. So after this energy level diagram, 3 level, 4 F2 and F1 are only we treat it as 1 because of both are close to each other. So metastable state 2E and 4A2 is the ground state here. So instead of that, all of you take E1, E2 and E3, and this is the E1 number. Actually, this is the E1, and these are E2, and this is the E3. And the wavelength produced in the ruby laser is 69.3 nanometers or 6943 angstrom units. Okay. Laser transitions occurred in between the E2 and E1. Before that, we achieved the population inversion between the E2 and E1 also. And applications already covered in the last class. So these are drawbacks. Now coming to the helium-neon laser. So wavelength produced in the helium-neon laser is 632.8. So I will explain using the whiteboard. So here we have taken the discharge tube. Discharge tube. Instead of ruby rod in the ruby crystal, here I am taking the discharge tube. Similar to the ruby crystal in the ruby laser. This is called as the discharge tube. Discharge. Quartz material is quartz. We made with the quartz. So in that we fill it with helium and neon. Helium and neon in the ratio of 10:1. If you have taken 10 helium particles, at the same time, you have taken only 1 neon particle. So in the ratio of 10:1, we filled helium and neon in the discharge tube. And two ends of the discharge tube are silvered. One end is fully silvered and other end is partially silvered. To get the laser, one end is we are partially silvered. So this is 100% silvered and this is a 95% silvered. These two are acted as a resonant cavity. So connected to the electrodes, these two electrodes are acted as a pumping source. And this is the construction part of the helium-neon laser. Similar to the ruby laser. So we have taken instead of ruby crystal in the ruby laser, we have taken discharge tube, the quartz discharge tube that is filled with helium and neon in the ratio of 10:1. And two ends of the discharge tube are silvered. So one end is fully silvered and one end is partially silvered. These partially silvered end we are getting from the partially silvered end, we are getting the output laser. So these connected to the electrodes which are acted as a pumping mechanism. Okay, so coming to the energy level diagram. Here instead of one energy level, here we have two energy level diagram. One is for helium and one more for neon. So here active particles are only neon particles because of in the neon energy level we are getting the laser transition. So helium particles are used to excite the neon particles. They are not involving directly in the laser transition. They are used to excite the neon particles from ground state to the excited state. We are using here helium particles. So that's why helium particles are not playing a role to get in the laser transition. Helium particles are playing a role to excite the neon particles from ground state to the higher energy state. So two energy levels are present here. One for helium and one for neon. So helium, I am taken helium energy levels here. Helium only 3, E3, E2 and E1 is the ground state. This for helium. And coming to the neon now. Neon having 6 energy levels. This is E6 and this is E4. In between we are having E5. After that E3, E2 and E1 ground state. The energy level of helium and E3 of helium almost all equal to E6 of neon. That's why I am representing here equally. The E2 of helium is equal to E4 of neon. That's why I am in the diagram also I am representing equally here. The energy of E3 of helium are equal to E6 of neon and E2 of helium is equal to E4 of neon. So using the pumping mechanism, what will happen? Wait. Sorry. So helium atoms are excited from ground state to the higher energy state using the pumping sources to the E3 and E2. By observing suitable energy, they are excited to the energy states E2 and E3. So E2, which are available in the E2 state, these helium particles are used to excite the neon particles from ground state to the excited state E4. So at the same time, which are available in the E3 energy states, These helium particles are used to excite the neon particles from ground state to excited state E6. Means helium particles are not playing a role in the laser transition. They are only used to excite the neon particles from ground state to E4 and E6 energy states. So, which the particles are available in the E2 states are used to excite the neon particles from ground state to E4. At the same time, these particles are E3 helium particles are used to excite the neon particles from ground state to excited state E6. Means we achieve the population inversion between the two states of energy levels. One is in between E6 to E5 by sending the particles from ground state to E6 state. So at a particular instant, what we are going to observe again? So E6 having more number of particles than the E5. Means we achieve the population inversion between these two. Again, these two also, E4 to E3 also. E4 to E3 also, because of, so we are sending the particles from ground state to E4 now. So at a particular instant, what will happen? The population inversion is occurred in between the E4 and E3 also. Means in the two ways we achieve the population inversion. So after the population inversion, getting the laser only remaining. So try to understand, we have instead of only one energy level, in the helium-neon laser, we are having two energy levels, one for helium and another for neon. So helium having only 3 energy levels, E1, E2 and E3. At the same time, neon having 6 energy levels up to E1 to E6. So the E3, energy of E3 of helium are equal to E6 of neon. At the same time, E2 of helium is equal to E4 of neon. That's why I'm equally representing also in the energy level diagram. So here also same thing will happen. So by observing energy, helium particles are excited to the energy states E2 and E3. So which are available in the E2 state are used to excite the neon particles from ground state to E4 at the same time from E3. So these helium particles are used to excite the neon particles from ground state to E6 energy states. Okay, so we achieve the population inversion here between the E6. Wait a minute. We achieve the population inversion between these two and these two also. So after achievement of population inversion, laser transition will occur between the energy levels. But here three transitions are possible. One is E6 to E5. One more is E6 to E3. So one more laser transition between the E4 to E3. So here 3.39 micrometers of wavelength is produced. So first laser transition between the E6 to E5. So the major transition 632.8 between the E6 to E3. So third transition E4 to E3 is 1.19 micrometers of wavelength. 1.19 micrometers of wavelength. So first laser transition between E6 to E5. E6 to E5. The wavelength is 3.39 micrometers. So second transition, the major transition between E6 to E3, 632.8 or 6328 angstrom units. So third transition E4 to E3. This is E6. E4 to E3. So here 1.19 micrometers of wavelength. These two wavelengths are negligible wavelengths. So the major transition between E6 to E3 will occur. So that is the wavelength is 632.8 nanometers or 6328 angstrom units. No, just okay, Amma. These are the three major wavelengths produced in the helium-neon laser. So E6 to E5, the wavelength is the three laser transitions are possible. One is E6 to E5, and another one is E6 to E3 is the major one, and E4 to E3 is 1.119 micrometers of wavelength, and 3 laser transitions. So after that, by the stimulator spontaneous emission, they are de-excited to the E2 and E1 again by interacting with the helium particles, and they are excited to the absorbing energy and excited to the energy states E4 and E3. This process continuously occurred between the energy states. Up to sufficient details, adi kuda 632.8 wavelength vacheyanta varaku kuda this process is continuously occurred in between the energy states. Okay, these two energy levels also presenting within the discharge tube only. This total laser transition occurred in between the discharge tube. And this is about helium-neon laser. So I'm going to share the PPT now. With the PPT, I'm going to explain again. Yeah. Helium-neon laser. The best known and most widely used helium-neon laser operated as a 632.8 nanometers or 632 angstroms of wavelength, red part in the visible spectrum, developed by Bell Laboratories in 1962. Neon is a gasless laser. Helium-neon laser is a gas laser. Is a continuous 4-level laser. So active medium is helium and neon gases in the ratio of 10:1 respectively. Only neon atoms are responsible for the laser action. Lasing action only takes place within the neon energy levels. Okay, helium are not playing a role directly. They are used to excite the neon particles from ground state to the higher energy state. So energy source is the 2 electrodes are fixed near to the ends of the tube. Okay. Coming to the construction, helium-neon laser consisting of a long, narrow cylindrical tube made up of a fused quartz discharge tube. I will tell you now. The diameter is also given here, 2 to 8 mm of length. Diameter is 2 to 8 mm and length will be 10 to 100 centimeters. That size is varying between the dimensions. The tube is filled with helium and neon gases in the ratio of 10:1. The pressure of the mixture of gases inside the tube is nearly 1 mm of Hg, and 2 electrodes are fixed near to the ends of the tube. Pass the electric discharge to the gas to excite the neon. Through that electrodes only, helium particles are absorbing energy and excited to the higher energy states E2 and E3. The optically plane mirrors are fixed to the ends of the tube. Means 2 ends are silvered here. Usually 2 ends of the discharge tube are silvered. The 2 are acted as a optical cavity. So one of the mirror is fully silvered, another one is partially silvered. That one we know already. So this is a diagram for that. Lasing action due to the neon atoms. So heliums are used for selective pumping of neon atoms to the upper energy level. I said you know. So which are available in the E2 states are used to excite the neon particles from ground state to E4. At the same time, which are available in the E3 states, that helium particles are used to excite the neon particles from ground state to excited state E6. So these are 3 transitions. So 3s to 3p level, giving rise to 3.39 micrometers. At the same time, remaining 2 also. See. These are the laser transitions in the energy level diagram. So 3 for E1, E2 and E3. Don't remember 2-1s, 2-1st. Don't remember like that. E1, E2, E3, like that only you remember. So for the helium, 3 energy levels are present, E1, E2 and E3. Right? For the neon, so see 1, 2, 3, 4, 5 and 6. Right? Here 3s is the 6th one, 3p is the 5th one, 2s is the 4th one, and 2p is the 3rd one. So 1s is second and the ground, this is the ground one. Okay. So by when the discharge electrodes release the energy, that energy absorbed by the helium particles and excited to the higher energy state E2 and E3. Right? So these particles are used to excite the neon particles from ground state to E4, and these particles are used to excite the neon particles from ground state to E6 energy states. So we achieved the population inversion between the E6 and E5 and E4 to E3 also. So after achieving the population inversion, three transitions are possible. One is E6 to E5, the wavelength is 3.39 micrometers. And one more thing is E6 to E3, then 632.8 nanometers or 6328 angstrom units. And one more transition between the E4 to E3, that is 1.15 micrometers of wavelength. After that, by the de-excitation process, either stimulated or spontaneous emission, they are de-excited to the E2 and E1. So this process continuously occurs. Okay, and this is about helium-neon laser energy level diagram. So applications widely used in the laboratories and supermarket to check out the counters. Barcode checking also we are using helium-neon laser. And these are some helium-neon laser applications. I am going to share this PPT after the class. All of you go with the PPT. Already I shared this module 3, I think. Even though I am going to share this PPT again. Applications. So after the applications of lasers, we are going to discuss about the applications of lasers in different fields. So what are the fields I am going to give? First one is the lasers in medicine. These are applications related to the medicines. So lasers in communication. How we are going to use the lasers in the communication. I will give some applications. Lasers in industry. Lasers in military. Fourth one. And lasers in computers. And lasers in thermonuclear fission. And scientific research. These are